Greetings. This grain training is a presentation that I made for my friends at TrueNorth, Lane Danielson, Matt Soden, and Jess Seeley back on July 25th, 2024. We're going to talk about mainly four parts. I'm going to just introduce myself and talk a little bit about my background. Then we're going to talk about grain dust explosions, specifically some case studies that I've had experience with, and grain engulfments and entrapments, some employee safety type information there, and then finally talk about some observations and how I feel near miss reporting, even if it's not a formal program, is very important in the prevention of accidents and injuries and dust explosions at grain facilities. So my name is Al Tweeten. I've worked in safety and insurance risk control for 36 years as my day job. I started at Growmark. I was a safety and compliance specialist for them for a few years. Then I went to work for MSI Insurance based out of Arden Hills, Minnesota. I was with them for quite a while, working strictly agribusiness, mostly co-ops. And then went to work for Berkeley Agribusiness. And lastly, at Nationwide Agribusiness, where I worked with TrueNorth as an agency and with Matt and Jess as co-workers at Nationwide Ag. During that time, and in addition to that, the 3 years since, I'm a farmer. I'm a row crop farmer in rural Joyce, Iowa, and I've worked side jobs for cooperatives in my youth and my younger days, and really enjoy working with agribusiness. I really enjoy what you guys do. You're very important, and I hope you recognize and have that kind of quiet confidence that rural co-op folks are known for. Just to put a little historic perspective on grain dust explosions, the worst month in history occurred in December of 1977. In that month, there were 5 elevator explosions in the United States, resulting in 59 deaths and 48 injuries. The worst dust explosion in that month was at Westwego, Louisiana, at Continental Grain Elevator, and it was during a shift change. 36 were killed and included 7 grain inspectors and some construction workers. But 36 were killed. There were 11 survivors out of the folks involved in that dust explosion. And it took them 10 years, but OSHA responded to that horrific month by enacting the grain handling standard 1910.272 that we all work under today. And personally, I think it's a great law. I know it's a pain to comply with it, but it's very meaningful. It has a housekeeping standard, and it tells you how to do it and what procedures you need to take to do it safely, and it requires records. It also requires preventive maintenance of critical bearings and the installation of monitoring systems at certain capacity and in certain locations, and there too maintaining records. It also talks about how to do hot work and document that with lockout, tagout, bin entry procedures, and that kind of thing. In spite of our best efforts, dust explosions are still happening. Here's a list of dust explosions that have happened in the last 10 years and the number of killed and injured workers due to those explosions. Here's page 2 of that 10-year list, and page 3 of that 10-year list. So in summary, from 2014 to 2023, there have been 81 reported dust explosions with 11 deaths and 99 injuries. And I know from my experience, there are several minor explosions that just involved a grain leg or resulted in a flash fire, and there simply wasn't enough fuel. There wasn't enough dust to cause an actual explosion that caused enough property damage and carnage to get reported, and which is a good thing. But we need to do everything we can to reduce the likelihood of a grain dust explosion. Whenever I have the opportunity to talk to a group of people about grain dust explosions, I usually reference this DeBruce grain elevator explosion. I know it happened a long time ago, but the reason why I feel it's a real benefit to share information from this report is that it was so extensively studied. Um, there's a 353-page report that was commissioned by the Department of Labor, and it was very thoroughly investigated by representatives from from industry, from insurance companies, from the government, and the report itself is really, really well done and very thorough. There were 7 killed and 10 injured in this grain dust explosion. And here are some pictures of the carnage. And in this picture, you can see they're bringing a man basket up to rescue some folks via crane, kind of as this is unfolding. More images of stranded workers, and these are the lucky ones. So the summary of this study, basically it's a deliberate decision, and they allowed massive amounts of fuel to be created and distributed throughout the facility. They had long failed grain dust control systems that were not in operation. They had abandoned preventive maintenance of the elevating equipment. They had not replaced bearings. They had not been providing proper grease and maintenance, and they basically made a dust explosion inevitable. So they were able to determine the cause of this dust explosion, and the facility itself operated with 4 round the world belts that moved the grain through the facility, and they had trippers and hoppers that collected the grain and would funnel those onto those belts. And this is a roller under one of the belts in one of the tunnels of the grain facility. So over time, the belt rubbing over that seized roller caused enough friction and heat to start a fire, and a fire smoldering in the dust, and eventually that smoldering fire was enough heat to ignite the dust that's inevitably in suspension in that facility, especially in absence of the dust control systems that should have controlled the dust but were not in operation. While they identified the cause of this specific dust explosion, they also identified conditions that existed elsewhere in the facility that could have caused a dust explosion as well. Here, this is the trunk of a grain leg in the facility, and you can see how the belt had been running out of alignment long enough to cut a groove in the trunking and to also discolor the paint. And it's fairly obvious that there was a lot of heat being generated by this belt running out of alignment. And these are some rub blocks, again, from a trunk of a grain leg that would signal to the belt being out of alignment, and these rub blocks were not operational, and you can see the grooves that the belt had cut in these rub blocks. And these are pictures of the dust in the dust control system that was not operational, and the equipment was there. It was simply not maintained and not kept in operation. At the trippers and at the hoppers and transition points, there would have been dust control originally on this facility or retrofitted to keep the dust levels down, and none of that equipment was operational. Here's a picture of the dust levels up in the gallery or in the Texas house of this facility, and you can see there's plenty of fuel here. This dust needs to be at an 1/8 inch or less in the critical areas of a grain elevator, and obviously in this case the dust levels were much higher. More examples of the dust level in the facility, and keep in mind after that primary explosion, all of this dust is shaken loose and suspended in the air to cause the secondary explosions that continue to blow the facility apart. Here's how the ceiling of one of the tunnels was deformed by the dust explosion. This ceiling would have been flat originally before the explosion. Significant amount of power and pressure to cause this much damage in a facility. There were also non-standard electrical conditions in this facility. That top left picture is some non-standard wiring in place. I believe this is in the Texas house, as was this regular extension cord and trouble light being used, and that TV was also in a classified Class 2 Division 1 or 2 location, and certainly should not have been there. Here's the before and after picture of the facility. Obviously, when we put these back, we don't enclose the workhouse or the legs anymore, so that is open air. And you can also see on the right where all the damage occurred was replaced with open conveyors and more traditional distributor systems, and no longer have the open belts like it did prior to the explosion. Another case study I like to talk about is the 2021 dust explosion in Jefferson, Iowa. And the reason I like to talk about this is because this is a facility that I have been through hundreds of times during my 36 years in the grain insurance business. And I was lucky enough back many years ago to work with the management at what was West Central Co-op then, and they kind of took me under their wing and taught me a lot about prevention of grain dust explosions because of some past experience that they had at this facility. But we'll start by talking about this dust explosion in 2021. It was a miracle that nobody was killed or injured in this. What had happened is they had some grain go out of condition in a steel bin, and they were in the process of transferring that grain so that they could deal with it. And when doing that, they moved some burning or smoldering grain into their workhouse and caused the explosion that you see here. Well, as I mentioned in the earlier slide, my first experience at this facility was in the late 80s when the senior management at West Central Co-op put me in their car and brought me to Jefferson and grabbed the location manager from the office, and they walked me through this facility and talked to me about what had happened, who was killed, the process they went through in investigating and working with OSHA. They talked about having to go and knock on the door and talk to the widows and the surviving family members, and it was a very emotional discussion about what they went through at the time of this dust explosion, and it left a huge impact on me, and it absolutely changed the way I did my job. And that's why I like to highlight this a little bit, because this facility, when I used to work with them, that was so clean. This is where I would take my reinsurance folks to show them how a grain elevator can be run and can be clean and can be kept clean, and was really not a big risk to them. And clearly, a lot of that was because of the emphasis that they made, and they basically asked me. They said, "Hey, you got to keep us safe. I want you through here. I want you to come in unannounced. I want you to, be very honest with my people and with me on what you see, and check our records, make sure we're doing things right." And that was my experience when I worked with these folks, and I just wanted to share that with you. So this is a side-by-side comparison of the damage that occurred in 1974 on the left and 2021 on the right. It's a different angle, but it's the same side of the elevator that you're seeing here, and you can see the damage is actually worse from the most recent dust explosion. They were just lucky that no one was actually in the head house or in the work floor at the time of the dust explosion. And here's the back side of the elevator from the 2021 explosion, and you can kind of see the legway there and the interstice and the bin tops and the damage that was done. If I understand the 2021 explosion correctly, the origins of this were in the tunnel or conveyor underneath this steel bin on the right, and that primary explosion transferred the ignition to the workhouse where the secondary explosions caused the significant damage to that cement elevator. So this is what was left after all the cleanup, and clearly there was significant damage to this facility, and it was subsequently torn down and replaced with a couple of concrete silos and an outside leg or legs. Just want to share a few housekeeping slides. When I was working in the field just a few years ago, this is some of the things I would find, and quite often the housekeeping records would show that this was cleaned, on 2 or 3 days ago. And when I'd go up in the man lift and walk across the bin tops or down in the tunnels, I'd see housekeeping that clearly hadn't been done for a long time. That lower right picture, you see the corn there is sprouting, and it's growing on that roof. You've got to maintain your housekeeping. It's very important. Even though this doesn't, contribute necessarily to a dust explosion, it certainly does contribute to the deterioration of that roof. And if you cause some heat or some spalling, the watertight integrity is gonna fail. Then you're gonna start getting water into your bins, and that is gonna cause spoilage and heat and grain hanging up and all kinds of issues that you just don't want. So housekeeping is critical for a number of reasons in a grain facility. Just another example of a leak that generated and just didn't get addressed, and it amounted to a real mess that needs to be cleaned up and maintained. And this is just an example of some deferred maintenance. We've got a ratchet strap mixed in there, a lot of duct tape, and we've got a crappy ladder there as well that's upside down and bent, and just a condition that exists at the facility that just needs to be cleaned up and fixed. And this is just my last housekeeping example I'm going to give. Again, this is a facility where their housekeeping log showed they had cleaned this boot in the last week, and no, they hadn't. I mean, the levels of dust hanging on the cobwebs and all of that is just it just shows that the housekeeping has been very lax. And this is the kind of thing that causes a tremendous amount of fuel if you ever do have an ignition source and a primary explosion. We can't talk about grain dust explosions without talking about bearings. Bearings are the leading cause of grain dust explosions, and they require a lot of effort in record keeping and in preventive maintenance. And again, the grain handling standard specifically addresses preventive maintenance and critical bearings. And as I said, bearings require periodic maintenance and changing them out. And a lot of these guidelines are found in the original manuals that come with the equipment that you have in your facilities. And obviously the age of our facilities, sometimes that's not an easy thing to do. So for that, you need to kind of work with your millwrights or your construction folks and put a plan together and make sure that these bearings are lubricated appropriately and maintained and changed out at the intervals that are recommended. Here's an example of a form for bearing analysis and the schedule that you would use. You have different types of bearings. This happens to be a bearing that is not sealed, but rather uses a little grease barrier between the pillow block and the bearing or the flange that keeps the contamination out. It relies on this little layer of grease to keep moisture and dirt out of the bearing. And here is just an example of how some facilities maintain their records. This is a clipboard. The clipboard on the left is the housekeeping records, and the clipboard on the right are maintenance records. A lot of these records now are maintained in an app or online or on the computer, and that's fine. They just need to be maintained and audited to make sure that they're actually being done as required to prevent a problem. A lot of the bearings in our grain facilities are hard to get to. This is an example of a leg head in an older grain facility, and you can see on the kind of on the left side there they have a remote zerk that actually feeds up into the bearing to make it possible to grease it from the working surface and not having to use a ladder. So just think about that as you're going through. The easier you make the preventive maintenance, the more likely it is that it's going to occur. Another part of the grain handling standard has to do with hazard monitoring equipment, and we're going to talk a little bit about that. This incident happened, this dust explosion happened back in 1994 in Gowrie, Iowa, and I was very familiar with this facility back then, and I was able to get on site shortly after the dust explosion. I've got a slide tray somewhere with a lot more pictures, but this is all I have right now. This dust explosion caused one fatality and one very serious injury, and the elevator worker was standing on the dump grates when the explosion occurred, and she was literally blown out of her boots and was killed. Her body landed on the roof of the flat grain storage adjacent to the grain elevator. And the truck driver was down in the boot investigating the belt speed alarm, and he suffered very serious burns when the explosion flashed past him on its way out of the facility. The cause of this explosion was actually a slipping belt, and a fire started at the at the head of the leg when the belt slowed down and the belt was slipping. And it turned out the speed monitor was installed incorrectly on this leg. Nothing was connected to the 10% slowdown alarm. Instead, the 10% slowdown alarm was connected to what should have been the 20% shutdown. And then there was actually no automatic shutdown that should have been installed at that 20% level. So the truck driver just happened to be in the tunnel to investigate the alarm when the explosion occurred, and the worker was on top of the grates and was killed when this explosion occurred. Another example I like to share as it pertains to HAZMON equipment is this dust explosion that happened again a long time ago. This was in 2009 in South Dakota. This is one of South Dakota wheat growers or Ag Tegra's facilities back in the day. And this was a bearing failure at the leg head in a relatively new grain facility. So in this case, a bearing failed on the leg, and the primary explosion occurred in the leg, and it was able to vent through kind of a workroom in the concrete elevator, and this is the door to the outside where the explosion was able to vent. And I can't remember if this was a scale hopper or a cleaner of some kind, but this is again where that primary explosion was able to vent relatively harmlessly to the outside. Here's the bearing that failed, and you can see it's a very large bearing. The shaft diameter is roughly the same as a 5-gallon bucket, so a big bearing, and it was relatively new. So this was a case where the hazard monitoring would have been very helpful in identifying that this bearing was getting hot and about to cause a problem. Unfortunately, the watchdog system in this facility was set to Celsius instead of Fahrenheit, and the set points were such that the alarm didn't indicate that the bearing was hot, and it allowed the bearing to get hot enough to cause this explosion. Okay, I've got a couple pictures here. These are some temperature sensors. The one on the left is obviously on an electric motor, and then the one on the right should be connected to that gearbox, but it has been disconnected. And in talking to the facility folks, the reason it was disconnected is because it was creating these false alarms. Well, I'm not so sure they were false alarms when you look at that gearbox, and the picture doesn't really show it very well. But there, the gearbox is leaking, and in fact, it was low at the time of my inspection, and I'm guessing it actually was getting hot, and that the alarm that was going off because of that gearbox temperature was indeed justified, and that's a problem. When you have an alarm going off, you need to investigate it and fix it. Don't just disable or disconnect the sensor. A lot of you are going to recognize this. This is a control touchscreen for a grain facility. And on a lot of these modern controls, the HASMON screen is actually integrated into the same system as the control screen. And here you can see the set points on all the bearings and the legs, and the speed sensors are going to be on another screen. And this is just some really great equipment. And if you work at one of these facilities, I really encourage you to become familiar with your HASMON systems and to audit it yourself. Check and make sure that the set points make sense. And you might need to vary these depending on the weather conditions and the ambient temperatures. In the middle of winter, when it's 30 below zero, you're probably going to want to have different set points than in the summer when it's 100 degrees with the sun shining on the bearings. So just kind of keep that in mind as well. Educate yourself, get familiar with the equipment, and change these set points as it makes sense and as you're instructed to, by your management and your safety personnel. Here's just an example of another type of alignment sensor on a grain leg, and these are very critical in maintaining the safety of a grain handling operation. And again, inspect, and as you're walking by something, look and make sure they're in place and doing what they're supposed to be doing. Here we've got an example of, in addition to the bad housekeeping, we have an example of rub blocks that aren't maintained and in place the way they should be on a grain facility. Electrical systems are another source of heat that can lead to a dust fire or a dust explosion. This is something we see quite often in grain facilities. In this example, they're running a sump pump using a pigtail that takes the approved, intrinsically safe, dust-tight electrical system and just turns it into a standard power cord. This is not a safe operation in a grain facility. There's just too much dust present. If you need a sump pump, you're going to have to find an intrinsically safe sump pump that is not going to cause a potential ignition source in the dusty environment. This is something else we see quite often in grain elevators. We're in a control room of a grain elevator, and they've opened a panel and they're cooling off. We've clearly got a starter, a motor starter or motor control, a magnetic starter that's been overheating, and the thermal has been tripping out on it. So they're solving that problem with an electric fan blowing air on the starter. This is a bad idea on a number of levels. First is you've got an open panel with high voltage exposed to your workers, and secondly, you probably have a voltage situation where your contactors or your connections are loose, creating that heat, and you're sending you're not sending clean power to that equipment, which could cause premature failure and other concerns. So these situations just simply can't be allowed to exist in your facility. Part of your maintenance program at your grain facility needs to include a good clean and tighten program with a licensed electrician who comes in periodically and just maintains the equipment and makes sure everything's clean and tight. I'm a huge advocate for thermal imaging, infrared analysis of your facilities. I can't remember a time when we did a thermal analysis of a grain facility and didn't find at least one significant issue. And your insurance companies typically have the manpower and equipment to do this. And I would encourage you elevator folks to have your own thermal imaging camera to do this type of work yourself. You don't have to necessarily open the panels. You can find a lot of issues by just taking the camera out in your facility while it's in full operation under full load and looking for hot spots. Not only will thermal imaging find electrical concerns and loose connections and malfunctioning equipment, but it's also going to find hot bearings or hot motors or other issues that you might not otherwise have a sensor on or that you might not otherwise identify. And I would also encourage, if you have your own equipment, utilize your insurance company folks to train your people. There are some limitations with thermal imaging. If the object that you're taking the temperature or you're taking the image of is shiny and reflective, it's going to give you the temperature of what it's seeing, of the reflection. It's not going to give you the temperature of the object itself. And you might need to put a piece of black tape or some flat black paint on what you want to take the temperature of so that you get the correct reading. There's reflectivity and emissivity, and you kind of have to understand those principles and make sure that the temperature reading you're getting is accurate. And for that, you do want to have a little bit of training and a little bit of understanding. Those of us that have done it professionally, I personally have had a 40-hour training course just on thermal imaging. You don't necessarily need all that to identify a problem, but you do need some instruction to know the limitations so that you're getting some accurate readings. Now we're going to shift gears and talk about some employee safety stuff, specifically entrapment, engulfment, entanglement, and atmospheric conditions inside a grain bin. This chart shows the grain engulfment and entrapments in the last 12 years, and the trend is relatively flat. There's still way too many of these things happening out there. We should be getting the 2023 numbers pretty soon. This map shows the 2022 numbers as well as historic information. And unfortunately, our part of the country still is having a lot of these engulfments and entrapments in grain facilities. Most of the engulfment situations that I've worked with have been a result of complacency. We have folks that spend a lot of time around grain and they feel very comfortable and they're willing to put themselves in a situation that they certainly wouldn't put their kids or their, in a lot of cases, their employees, because a lot of these it ends up being a management level person who goes into a bin, maybe comes in early, maybe comes in on a weekend and does a task that they can maybe avoid some of the paperwork and some of the extra effort, thinking they're going to do it just like they used to do it. So anyway, complacency is something that I define as the more time you spend dangerously close to a recognized serious hazard and are not injured, not only do you not recognize the hazard, you actually feel safer than when in an unfamiliar setting absent of any recognized hazard. I also like to use a corn picker analogy, and a lot of you are too young to remember these corn pickers. Here's my dad actually running an old John Deere one-row corn picker quite a few years ago. But corn pickers were very hazardous back when I was a kid. And here's a little diagram from an operator's manual from back in the day, and it talks about the snapping rollers that actually gather in the corn into the picker, travel 12 feet per second, faster than you can let go of the stalk when it begins to enter the machine. I personally knew 4 area farmers where I grew up that had lost either the hand or their entire arm and had farmer's hooks because of corn picker accidents. The warning was clear. They knew that their neighbor had been injured, and yet they were still willing to take the risk to grab that plug while the equipment was running, and they suffered a serious amputation injury because of it. Some of what makes these grain bins so hazardous, you can have bridged or hung up grain, and when the grain flows, from whether just normal reclaim or if there's some material hanging up or some spoilage and you end up having an avalanche or a grain flow from that, you can be quickly engulfed in grain. Entanglement can be caused by sweep augers or any of the other kind of reclaim equipment or conveyors that are out there. And then there are also atmospheric conditions, toxins and dust, and then the absence of oxygen because of the spoilage or other things that could be welding or other things that could be going on inside that space. Typically, bin entry is because of some grain quality issues. You have some spoilage going on, and there's a lot of information on how to properly store grain. And there's every land grant university has guidelines on temperature and moisture levels when grain's going into storage. And if you have some grain that you know is an issue, you need to put it into a bin or into a holding facility where you can more easily manage it and where you know that it's not going to require entry to clean that out. New technology as well, monitor temperature change, and then CO2 levels are another good indication of spoilage or issues going on with grain quality within a bin. So grain monitoring equipment has really come a long way. You can monitor it remotely from apps. There are companies that specialize in installing temperature cables and the software and monitoring sensors that go with it. Here's just an example of some zero entry sweeps in some grain bins, and again, recognize that it's against the rules to be inside a grain bin with a sweep auger and the reclaim system going. So just be aware of that, and really watch to make sure none of your coworkers are breaking the rules and spending time in these facilities where there could be an engulfment hazard. Here are some examples of sump guards to kind of break up the material so that some spoilage or some bean straw or corn stalk don't plug your reclaim system. And I think the one on the left there is just like a 4-H or FFA project, and others are commercially available. But if you've got a sump that it's an older bin, a smaller sump, and you've had problems in the past, take some steps to make sure that you don't have to enter the bin to clear some blockage. I've got some examples from a Jeeps meeting a long time ago where Ed Kleinworth from St. Ansgar Mills here in Iowa actually shared some of the tools that he developed to use in a grain facility. This one is just a simple cordless drill with a piece of rod that's bent on it to clear a plugged grain situation. Here's another system that Ed developed, just a kind of a stir stick using bearing flanges and trailer ball for a trailer hitch. And in this situation, Ed is just he's just welded some strap iron to a piece of metal rod that extends to the outside of the bin, and they can put a pipe wrench or something on it and swing the strap iron up through the blockage and clear it so that it'll feed into the reclaim auger. Another aspect of preventing this type of engulfment or bin entry is awareness training. And you need to do both classroom and hands-on at your specific facility to train on preventing these types of accidents and injuries. Good quality grain can have an angle of repose ranging from 26 degrees to 15 degrees. In a 90-foot diameter bin, which is a fairly common bin size these days, that can be a 10-foot difference. And that's if the grain is of good quality. You add some spoilage hanging up on the sidewall, or some chunks of grain, or some fines or some things, and that angle of repose can range a lot more, and you can actually have a much deeper difference there. So you have to really be careful, and that's why bin entry is just very discouraged, and you don't want to go into a grain bin unless you absolutely have to. So I'm also a very big advocate of simulated entrapments. I think your employees you're much less likely to put yourself in a dangerous situation if you've actually felt how helpless it is to be buried even up to your knees and waist in grain. And going through these simulations where your rescue personnel will get you out using cofferdams and using a team approach is, I think, very effective in teaching the importance of staying out of the bin, and also gives you a chance to make sure that your emergency action plan will work and that you'll have the right people available to get somebody out of a bin should they become trapped. If you have to enter a bin, you've got to follow safe procedures. Lock out equipment, check the air quality. You have to have a harness and a lifeline on the entrant. You have to have a dust mask if the environment is dusty, and you have to have an attendant manning that rope and being there to call for help should you need it. And by lockout, that goes beyond the electrical. It also has to lock out the mechanical, pneumatic, and anything that could enter that bin by gravity flow. Air quality is another big concern inside a confined space like a grain bin. You have to make sure there's enough oxygen to support life. You also have to make sure that there's no flammable vapors or any toxins in the air that you're breathing. And then, of course, just regular old dust is also a concern inside a grain bin. And the causes can be spoilage, mold, welding. We had that case in Waverly several years ago where the father and son passed away due to the welding gases displacing oxygen. And you've also got fumigants that you're possibly using. And then also keep in mind you have aeration in these facilities. Use that, change that air, bring some good quality air in before you attempt an entry. Doesn't mean you can't test it. You still have to test the air quality, but use that aeration to bring some fresh outside air into that bin before you test it and do the entry. We talked briefly about the harness and lifeline, and that I want to focus a little bit more on that. You need to make sure that that attachment point is in the center of that bin. All too often I see lifelines being used and the angle of the grain and what's maybe hanging up on the sidewalls would still present a really high likelihood of engulfment should that grain flow. So make sure that a passing pulley is used and that you're attaching that lifeline to a point where it will prevent an engulfment. That attendant is a very important piece of this bin entry for communication, to make sure that that anchor point is attached and the passing pulley is used and that we're anchoring at the correct point, and to keep slack out of the lifeline, and if needed, initiate the emergency response if something bad happens. Just by way of an example, this is the actual entry permit of a engulfment situation that I was involved with in Ohio quite a few years ago. Employee went into a concrete silo cleaning beans, and the beans had actually had some quality issues, so they were hanging up on the sidewall. There was an attendant, there was a lifeline, there was a harness. Unfortunately, some of those beans, the reclaim was not running, but unfortunately, some of the beans that were hanging up came off the wall, engulfed the entrant to his shoulders, and there was really no way to get him out. It was an older concrete silo with just manholes both on the sidewall and at the top. There was no way to get cofferdams in. There was no way to get that employee out of the engulfment. By the time they cut holes in the sidewall and got the cofferdam in and got the employee out, about 8 hours had passed, and he suffered very serious long-term disabling injuries to his lower extremities and to his internal organs because things just started to shut down. So this was a very serious injury, a very expensive claim from a monetary perspective, and there was completely unnecessary. And when we kind of look through the confined space entry permit, he really, and this was actually the location manager that was involved in this engulfment, and did not do a very good job of filling out the form and did not address a lot of the hazards that were in the actual bin. And when we looked at the file, there were 5 permits on file from the previous entries that looked just like that one. Didn't address they didn't do the oxygen testing. They didn't address the situation with the beans hanging up on the sidewall, and they hadn't locked any of the equipment out. This is going to kind of end some of the grain engulfment discussion that I have, and I always like to kind of stop on a somber note. This is a man in Kansas who died in a grain engulfment situation. 59-year-old Dwayne Seafried, and the whole story is available in a video called Roberta's Request that was produced by Triangle Insurance many years ago. It's a great video. If you haven't seen it, I would encourage you to look it up. I'm sure it's available on YouTube. But this is a guy, hard worker. He was actually the chairman on the safety committee for this co-op in Kansas, and just a very tragic situation. He went in to do a job that he would not have sent his employees in to do, unplug some Milo, and the grain buried him, and he passed away because of it. And again, I'm not going to take a lot of time to talk about this, but this is a quote that CEO of that operation said. He said, "We're gonna," and this is a quote from that Roberta's Request video. Plan for inefficiency that will cause an employee to slow down and not put themselves at risk. If you can't do it safely today, then we'll wait till tomorrow. I think that's something that when we're dealing in a grain elevator, it's a high hazard situation. We just really need to slow down and assess the situation. And if you can't do it safe, we're just not going to do it. Of the 4 topics that I wanted to cover today, this is the one I kind of want to end on. In all my years, I have read thousands of depositions and seen thousands of interviews of witnesses and injured employees, and it's oftentimes you will hear someone say, "Oh, I wish I would have said something. I knew this was going to happen. You know, I'd watched him do that, and I should have stopped him." Um, and also as far as conditions, you know, oh, I knew that guard was off. Um, it was taken off to do some maintenance, and we never put it back on. Or we knew the lockout procedure didn't address that specific concern, and yet we failed to do something about it. It's very important that if you see someone doing something that's unsafe, say something, do something. If you're working in a condition that you feel isn't safe, if you're in a position to fix it, make it better. And if you don't, bad things might happen, and you're gonna have to live with the consequences of that. So again, I think I mentioned earlier, doesn't necessarily need to be a formal program. I love it when it's a formal program, and a lot of your safety folks have implemented a formal program of observations or near miss reporting. Follow it, do it. It's very important, and it'll lead to a safer work environment for you and your coworkers. So that's kind of what I wanted to kind of end on with this. Here's my contact information. If there's ever anything I can do for you, there's my email address, and there's my phone number. I appreciate you folks taking the time. There are some companion videos that are probably going to be posted adjacent to this. I'm going to put this as a video on YouTube, and there's probably going to be some other videos to show as well. I think there's a Royal Iowa dust explosion, the Jefferson dust explosion video, and maybe some other information that is out there that you could look at. Appreciate your time. Thank you very much.